Displacement. Now let us understand about displacement. Displacement is the actual change in the position of the body. Let us take an example. Let x1 and x2 be the positions of an object at time t1 and t2. Then its displacement, denoted by delta x in time delta t is equal to t2 minus t1, is given by the difference between the final and initial positions. Delta x is equal to x2 minus x1. We use the Greek letter delta to denote a change in a quantity. x2 is greater than x1. Delta x is positive. And if x2 is less than x1, delta x is negative. Displacement has both magnitude and direction. Such quantities are represented by vectors. For example, displacement of the car in moving from O to P. OP is equal to delta x is equal to x2 minus x1 is equal to plus 360 meters minus 0 meters is equal to plus 360 meters. The displacement has a magnitude of 360 meters and is directed in the positive x direction, as indicated by the positive sign. Similarly, the displacement of the car from P to Q is 240 meters minus 360 meters is equal to minus 120 meters. The negative sign indicates the direction of displacement. The magnitude of displacement may or may not be equal to the path length traversed by an object. Motion of an object can be represented by a position-time graph. Such a graph is a powerful tool to represent and analyze different aspects of motion of an object. For motion along a straight line, say x-axis, only x-coordinate varies with time, and we have an xt graph. Let us first consider the simple case in which an object is stationary. For example, say a car standing still at x is equal to 40 meters. The position-time graph is a straight line parallel to the time axis. If an object moving along the straight line covers equal distances in equal intervals of time, it is said to be in uniform motion along a straight line. The motion of a car that starts from rest at time t is equal to 0s from the origin O and picks up speed till t is equal to 10s and thereafter moves with uniform speed till t is equal to 18s. Then the brakes are applied and the car stops at t is equal to 20s and x is equal to 300 meters.